Hi, my name is Amit and I'm on the mission of making AI so simple that anyone can understand it. This episode is a continuation of our SVM series. In SVM, or we call it support vector machines, we have talked about how to find a hyperplane which maximizes the margin. In this episode, we are going to talk about two things. What is a support vector and what is the cost function of SVM algorithm. Let's suppose there are two classes, class A and class B. We have to classify them. So we have to find a hyperplane in such a way that it passes through somewhere between the middle of these two classes. But how do we find them? We select one hyperplane and we move that hyperplane towards the class A and we stop where we meet the first data point. Okay, let's say here. And similarly, we do the same thing. We move downwards towards class B and we stop whenever we touch a first data point. And then we draw the hyperplanes. This is hyperplane 1 and this is hyperplane 2, which is touching the data point. This is the margin. So margin is the maximum distance between these two classes. These points which are touching these lines or hyperplanes, these points are called support vectors. In this diagram you see only 2 points, but in general you will see many points which are on these hyperplanes, these boundary hyperplanes. These are called support vectors. Remember this. And intuitively you might be thinking that, to classify these two classes, we can draw a hyperplane which passes from half of this distance. So this will be our hyperplane. So this is the way a hyperplane is found. The equation of our hyperplane is wx plus b. So the cost function is 2 by magnitude of w. This we have to maximize. So what do we learn here? We have learned two things. One, what is a support vector? Support vector or the data points which are touching the maximum margin. And what is the cost function? Cost function is 2 divided by the magnitude of w. So save this reel if you learned something today and follow for more such content.